Okay, in today's session, I'll take one example where we are supposed to construct a payoff matrix, plus using the different criterion, we are going to find out the optimum strategy for the given problem. Okay, before we start this problem, please remember one thing, uh, whichever tool or whichever technique you're going to use to make a decision, it totally depends on the person or the person who's the decision maker. So, depending on the approach of the decision maker, he can make use of any one of the criteria or the techniques which are available. And again, based on his experience, his guts feeling, and many other factors, he can take some call. These tools which we are using is totally based on the previous data which is available. So, if a proper data is available to you, only then you can go ahead and use this criteria. It's not always said that you need to work out on the different types of criteria and only then go ahead and make a decision. Okay, all your strategies might work depending on the different situation or different state of nature, you can call it, or different scenarios. So taking decision is totally depends on the decision maker, his approach to the problem. Okay, but remember, these are just the tools which are available. Now, which tool you use and how you use and how you interpret the information or the outcome of the problems which after solving it, it's totally based on the decision maker. Now with this, let us take one example. So here we have an example of Hindustan Sales Corporation, who is a dealer firm in white goods. Okay, it finds that the weekly holding cost per unit of an air cooler is rupees 30 per week. Non-availability of an air cooler results in losing a customer, and the cost of losing a customer is estimated to be rupees 80. Now, the dealer expects that the weekly demand for an air cooler will range from 0 to 3 units per week. Okay, we are supposed to construct a payoff matrix, or you can call it as payoff table, and determine the optimal quantity to be stocked per week and the corresponding weekly cost using the different techniques. Now we are going to cover all the techniques in this problem. So like for example, maximum criteria, maximax criteria, Laplace criteria, regret criteria, Hurwitz criteria, where they have mentioned the, you can see the alpha value. So the dealer is optimistic about the demand for 60% of times. That means the value of alpha is 0.6. And we are also supposed to find out the other values if the probability distribution of the demand is given to you. That is your EMD. Okay, and the demand table, it's not put in a proper table here. So for demand 0, the probability is 0.1. For 1, it is 0.3. For 2, it is 0.4. And for the demand of 3 units, the probability is given as 0.2. Now, looking at this problem, can you tell me how many possible outcomes are there? Or you can call it as the state of nature. How many state of natures are there? And how many strategies are there? Anyone? You can put it in the chat if you want. So today, instead of giving you the direct answers, I would like you all to give me some answers now. That will make me understand whether you have understood the problem or I'm just moving ahead. 4 states of nature, right? So what are the 4 states of nature and 2 strategies? Okay, fine. Tell me the number of state of natures. The first one, you can say the demand is 0, like they have already given here. Demand is 0, demand 1, demand 2, and demand for 3 units. So these are my 4, you can say, state of nature. What about the strategies? Why do we say 2? I think it's not 2, but if you're saying 2, why you say so? Strategies sold or unsold. Okay, for air coolers. Fine, then there can be strategy of stocking number of, you can say, air coolers. So whether I should stock 1 unit, 2 unit, or 3 unit, or 4 unit, depending. So these are my strategies. What would be the first strategy? If there is a zero demand, then stocking 0 units or no units will be one of my strategy. Okay, so like we have 4 state of nature, we will also have 4 strategies depending on the stockings. So whether I should stock 0 units, 1 unit, 2 unit, or 3 unit. These are my 4, depending on the 4 state of nature, I have this 4 strategies. Because the maximum demand is given as 3. Okay. And they also have demand for 0 units. So if I move from 0 to 3, there are total 4 state of nature and 4 strategies. Okay. So 4 state of nature and 4 strategies. That is what we are going to have. Now, if you look at the problem again, okay, we are talking about the cost. We are talking about, holding cost of a particular unit. So for 1 unit of air cooler, okay, per week, I have a charge of 30 rupees. And losing a customer, again, if I'm losing a customer, the cost for losing a customer is estimated to rupees 80, right? So here, when I'm constructing my payoff matrix, it will be actually a cost matrix. Okay, it won't be a profit matrix. So the formula which I'll be using to calculate my cost will be the total number of customers. If I'm talking about the customers lost, the total number of customers lost multiplied by 80, because 80 is the cost of losing a customer, plus the number of units which are unsold at the end of the week, because the cost given to us is per week, right? This is my per week cost of holding that particular unit of one, you can say, one air cooler. So the number of units unsold at the end of the week multiplied by the weekly per unit holding cost, that is multiplied by 30. That will be my formula to calculate my cost. Okay, let us take a simple example. If suppose if I stock 0 quantity, okay, and there's 0 demand. So what is my cost here? Of course, logically, no need of doing any calculation. The cost will be 0. Okay, let us consider the other way around. If suppose I have stocked 0 units and there is a demand of 1 unit, that means I'm losing my customer here. Okay, so if I use the formula, number of customers lost will be 1, and the cost of losing the customer will be 80. So 1 multiplied by 80 plus the number of units unsold at the end of the week, because I do not have any units stocked. There's no question about unsold units. Okay, so that will be 0 multiplied by whatever the value is, that is 30. So my overall cost here for S0 and N1 will be 80. Got it? So using this formula, I want you all to construct the cost matrix first, or you can call it as your PF matrix, and tell me the answers, at least for the first row. Let us say we'll take the state of natures as N0, N1, N2, and N3. Okay, N0 is for demand for 0 units, N1 for demand for 1 unit, N2 will be for demand for 2 units, and N3 where the demand for 3 units. Similarly, we'll have S0, S1, S2, and S3, where S0 is the strategy to stock 0 units, S1, the strategy to stock 1 unit, S2 and S3, respectively 2 units and 3 units. Okay, can you give me the value for the first row? That is strategy S0 with the demands as N0, N1, and N2. Okay, I will repeat this again. I'll repeat from the beginning. Okay. Now, looking at this problem, if you look at the problem, we are talking about only cost here. Okay. We are talking about cost of holding that particular unit for the whole week. If it is not sold, the cost is coming to 30 rupees per unit per week. And then if suppose it is unsold, again, non-availability of uh, an air cooler, I'll be losing a customer, right? And the cost of losing a customer is given as rupees 80. Now, using these two values, if you look at these two values, and if I have to construct a payoff matrix, immediately you can tell that it is a cost matrix and it is not a profit matrix. I hope this is clear. Fine. Again, as we have seen, there are 4 state of natures and 4 possible strategies which we can apply. The strategies will be of stocking the number of units of air coolers, starting from 0 up to 4. And similarly, there are 4 natures. There is demand of 0 unit, demand for 1 unit, then demand for 2, and demand for 3 units. Now, when I'm calculating the cost for a particular combination of strategy and the demand, let us take the, you can say, combination of S0 and N1, where S0 is to stock 0 unit and N1 is demand for 1 unit. Now, if the formula I've already given you, the formula is number of customers lost multiplied by the cost of losing the customer. Okay. Now, if I do not have any stock with me, that means I'm going to lose a customer and there is a demand for 1 unit. So 1 customer is lost. Okay. And the cost for losing a customer is rupees 80. So 1 multiplied by 80 will give me the cost for losing the customer. That is 80 rupees. Plus the cost, the number of units which is unsold multiplied by the weekly per unit holding cost. Now here, because I do not have any units with me, because I'm using strategy, the first strategy of stocking 0 units, okay, this value will be 0. So the cost for, let us say, stocking 0 unit and demand of 1 unit is coming to rupees 80. I hope this is clear. Now, using this formula where we can say cost equal to number of customers lost multiplied by cost of losing a customer plus the number of units unsold at the end of the week multiplied by the weekly per unit holding cost, I can construct my cost matrix. So I want you all to give me the values, at least for the first row or the first strategy, that is S0, for all the state of natures from N0, N1, N2, and N3. Anyone with the values? Okay, no one. Let us see the calculation. I'll just show you the solution for the matrix. Okay, so we have 4 possible outcomes and we have taken this values like this. You can note it down. Okay, which I've already explained you. Similarly, we can have the possible strategies. So I'll keep S0 for stocking 0 units and so on till S4 or S3. In the formula, the payoff can be calculated using this formula here. Number of customer lost multiplied by the cost of losing a customer plus the number of units unsold and multiplied by weekly unit per unit holding cost. So if you do the calculations, now this is my first calculation for S1, N0. Similarly, you can do for the others. These are my other calculations. So please go through it. If you have any doubts, you can ask me the question, or else I'll just move ahead. Fine. So I think how to calculate the cost is clear. Now, after calculating all the values, I'll get a matrix which will look like this. This is my cost matrix. Now, all the techniques or the methods which we have learned for decision making is based on, you can say, gains or your profit matrix and not on your cost matrix. So what I'm going to do is I'll be converting this profit or the cost matrix into a profit matrix, or you can call it as a loss matrix into a gain matrix. Okay, there are two ways of doing it. The first way is, you can say, the simplest one, where you just convert the positive numbers into a negative number. So multiply all the units or all the payoffs by -1, and you'll get the values as, say, 0 remains 0, 80 will become -80, then -160, -240 for strategy S0, and so on. Okay, I will prefer using the other strategy. The other strategy is to find the maximum payoff in the matrix, which is, I think, in this 240. This is my maximum. Okay, and subtract all the other payoffs from 240, so that I get, let us say, the first one, if this is 0, 240 minus 0 will give me 240. Okay, then 240 minus 80 is going to give me 160, and 240 minus 160 will give me 80. Like this, the matrix which I'll be getting will be your profit matrix. Okay, I hope this is clear. Now, there's a reason for using the second strategy, which I'll be sharing with you later on. So I'm not converting my matrix into negative. So I'm not multiplying that by -1 and getting the negative values. Now, once we get the profit matrix, my matrix will look like this. Okay, so this is my new matrix, you can say. And I'll be doing the calculation. So I've added 4 more columns here. So the first one is your minimum profit, maximum profit, average profit, and expected profit. Now, how you do the calculations? Simple, find out the minimum value from each strategy, put it down here. The one which is maximum is known as your maximum value. Okay. Now look at the second column here, maximum profit. In all the strategies, the maximum value is 240. And because all the values are same, okay, and the maximum of the maximum is 240, so all these strategies from S0, S1, S2, S3 can be used, okay, in this approach. If I have to use the maximax criteria, then whether I use strategy S0, S1, S2, or S3, it hardly matters. Okay, that will be my strategy which I can use. Whereas in the first case, where I'm using the maximum criteria, S2, which is corresponding value of the maximum, or you can say maximum value, that is 160. So S2 is the best strategy, that is of stocking 2 units of air cooler, will be the best strategy in this case. Now, if you remember this criteria, that is maximum criteria, is more of a pessimistic approach. Okay. And your maximax is your optimistic approach. So in the optimistic approach, I can make use of any of the strategies. Now coming to your average profit is nothing but the Laplace criteria, okay, where it is a very rational approach. What we do is, now this is very interesting, pay attention to this one. Now in many books, I have seen that while doing the calculation of your average profit, for example, in this itself, what the authors have done is they have taken all these four values. Okay. Now, because one of the value is 0, while finding the average value, they have divided it by 3 and not by 4. Okay. So if you add this values up, 240 plus 160 will give me 400. 400 plus 80 is going to give me 480. Now 480, if I divide this by 3, I'm going to get a value like around say 160 something. Okay. So in many books, I have seen that because they have avoided this 0 and considered dividing by 3 and not by 4. But I would prefer to divide this by 4, because if you look at the definition of Laplace criteria and the method which they have mentioned, the formula which they have clearly mentioned that you have to make use of the total number of state of natures. So if I have 4 state of natures, I have to divide by 4. It's very simple. Okay. And whether you divide by 3 or by 4, because all the values, if all the values is having, you can say a 0 in it, then it will hardly matter. But now in this case, if I divide the first number by 3 and the next number or the next sum by 4, okay, it will give me some different picture altogether. And there's the reason this, as I told you, this figures, the values which I get here are just the indicators, or it is just going to help me make a decision. Okay. So do not rely on these figures too much. Okay. It just tells me, it helps me take a decision to make which, to execute which strategy, to apply which strategy in a particular given situation. Is this clear? So remember this, whenever you're going to calculate the average values, okay, or whenever you're using this Laplace criteria, see that after getting the sum of all the values, all the payoffs, divided by the total number of natures and not the total numbers, and avoid 0. Please do not do that. Okay, so using the Laplace criteria, I'm getting maximum number as 197.5, which is the corresponding, okay, the corresponding strategy is S2. Again, that means I need to stock 2 units of air cooler, which will give me the best result. Now, using the expected profit, finding of the expected profit, we have to make use of the Hurwitz criteria. Okay, so your expected profit, which is based on the optimistic value of alpha. The alpha value is given as 60%, or you can call it as 0.6. So 1 minus alpha will be 0.4. What is the formula here for Hurwitz? You have to take the maximum profit or the payoff from here, multiply that by alpha, that is 0.6, plus 1 minus alpha, that is 0.4, should be multiplied by the minimum profit. Okay, so in the first case, it will be 240 multiplied by 0.6 plus 0.4 multiplied by the minimum profit, which is 0. And it is giving you 144. Any doubts here? So like this, you calculate the expected profit and select the maximum profit in that, which is in this case is 208. And again, using Hurwitz criteria, I can say that the optimum strategy would be S2, that is talking 2 units of air cooler. Clear? So we have completed the first few answers. That is your maximum criteria, maximax criteria, Laplace criteria, and your Hurwitz criteria. The fourth question was to find the regret criteria. Okay. So to do that, first of all, I need to find out the regret of the payoffs. How do you do that? Anyone? You have to take the maximum value for each, you can say, state of nature and subtract across the strategies. Okay. So if you can do it and tell me the values. Anyone? No one? Okay, so in the first one, I'll just take an example of the first N0. The maximum value is 240. Okay, so 240 minus 240 will give me 0 here. Okay, 240 minus 210 will give me 30. 240 minus 180 is going to give me 60. And 240 minus 150 is going to give me 90. In the next state of nature, the maximum is again 240. So I'll use 240 to perform the calculation and get the values. Now, this is some explanation which I have given. If you want, you can just take a screenshot of this. Let's go ahead. The Hurwitz criteria, which I have done the calculation, you can note down. Okay, using the regret criteria for N0, this is the formula which I have given you to find the regret for S0. 240 minus 240 gives you 0, and so on. And we get the table like this. So this is my final table, okay, of regrets. And as you can see here, I'm getting zeros everywhere. Okay, so in each state of nature, there's at least 1 0. Now, how do I get the maximum regret? What are the maximum values for each strategy? Note it down, okay, and find out the minimum of the maximum, which will give me the minimax regret value. Now, again, the minimum value among this maximum is coming to 80, which is referring to the strategy S2. Okay, so we can say that the optimum strategy would be S2 in this case as well. Any doubts in this example here, especially the regret? No. Okay, great. Let's go ahead and solve the last one, where we are actually solving it using the properties which are available to us. So we are supposed to calculate the EMV. Okay. For N0, they have mentioned what is the probability, 0.1. For, sorry, N0 it is 0.1, N1 it is 0.3. For N2 it is 0.4, and for N3 it is 0.2. So I'll write the table again, especially make use of the profit matrix here again. Okay, so I'm using the profit matrix, and you can see these are my probabilities for that particular nature: 0.1, 0.3, 0.4, and 0.2. Use these values to do the calculation of your EMV, and the one which is the maximum value, which is coming to S2 again, which is 209, will be my optimum strategy using this particular technique. Using EMV, you can say expected monetary value. Okay, so we suggest you can put down all the calculations if you want, and you can write the answer. So that's my answer, final answer for the last question. Any doubts, any questions you have?
No, sir.
Okay. I want you all to practice this because soon I'll be conducting some tests. Okay, for you all, I want to check how many of you have understood and which are the topics which need some, revision or something if possible. Clear? So we will stop here today. When we come next, I want to start game theory. There are two units, not two units, two chapters which are remaining in the fifth unit. The one is your game theory, and the other one is your sequencing problems. Okay. So for game theory, I'll require more sessions because there are different types of strategies which are available, different types of games which are available. Basically, there are different techniques of solving the games problem. So one is your pure strategy game, and the other one is mixed strategy game. And there's a technique called principles of dominance, which can be used to solve such problems as well. Okay, and we'll also talk about the limitations of your game theory as well when we come next. Okay, so we stop here today. Uh, and whenever you have doubts, as I'm always telling you all, please practice. If you have doubts, let me know. Thank you for joining the session.
Thank you, sir.
Yeah.